So I'm John Marshall. I'm CCIE routing and switching and service portal lab certified. My CCIE number 29573. Okay, so we're going to discuss about multicast technology today. In company we using three technology in the network environmental. So we using unicast and broadcast, multicast we using. But when you go for audio and video application, they will give more preference for the multicast technology. They never use the unicast and broadcast. Okay, but if you go for any company or any TV station or any radio station, they'll give more important for multicast. They never use other technology. So we're going to discuss about why they're not using unicast and broadcast, why they're not using. I'm going to give all the reason. Okay, so we will take some example. We'll take one headquarters office and we'll take a two branch office, so all connected through the internet. Okay, so in a headquarters we conducting some web seminar, we conducting some Cisco seminar we conducting, so we want to telecast the stream to all branch office, branch 1 and branch 2. Okay, in branch 1 and branch 2 we using 5 users were watching. Okay, in branch 1 5 users are watching, and in branch 2 5 users are watching, just for example. Okay, watching, so totally 10 users was watching the stream. Okay, so we have source in the headquarters office. Okay, so we have one source and we have the 10 destination. Okay, so and one more thing, we sending the same stream, we sending the same data to all 10 users, all 10 destination device. Okay, so when you use the unicast concept, it's a one-to-one concept. Okay, it's not a one-to-many or it's not a one-to-all, it's a one-to-one concept. Okay, so that means in the packet you will be see the one source and one destination you will be see. You got it, right? That means you should send 10 times you should send the data. You got it, right? So that means each stream it take a 1 MB size. That means it utilizes the 10 MB bandwidth, because we have 10 users and we have 10 destination. So we want send the video stream, we want send it to all 10 devices. So it take the 10 MB bandwidth. Okay, and it take more processor too. Okay, so what my conclusion? It taking a lot of bandwidth it utilize, and it utilize the more process. So that's the problem in the unicast. That's why they're not using the unicast technology. But if you go for broadcast, in the same place if you apply the broadcast technology, if you use, it's a one to all concept. You got it? It is a one to all concept. When you send the stream with the broadcast address, it reach all the user, it reach the all 10 user it reaches. Okay, but the problem was, we can say it's saving bandwidth, but problem was it will hit all other users also. It get in branch office you have some 20 users, in branch 2 you have the another 20 users. Okay, but actually 5 users only listening in each branch office, but actually it hit other 15 users also to go and hit it unnecessarily process. So in broadcast my conclusion, bandwidth saving it, yeah, that's I agree that, but process we wasting a lot. Okay, but in unicast we wasting a lot of bandwidth, but we wasting a lot of process. But in broadcast we saving bandwidth, okay, but we losing a lot of process. That means we unnecessarily wasting a lot of process, because it's unnecessarily go and hit, because it's a one to all concept. But if you go for the multicast, we saving bandwidth and we saving process too. So that's why multicast is a very better one. Okay, but for multicast we resort some IP address. It's a class D range, it's a 224.0.0.0. so that's the range we using for the multicast. Okay, so here we can pick up any IP address from the multicast, so that IP address we can assign for all 10 PC. Okay, so for example I'm taking 224.4.4.4 multicast address I was taking. Okay, so that I assign to the all 10 users, because they wanted to listen the stream, they want to listen the multicast stream. So just assign the IP address to the all the 10 users. Okay, and when you generate the stream, send it with the multicast address whatever we took, that's a 224.4.4. in this case the 10 users only just was in the online, they only listening for the multicast address, the stream only reached to the 10 user, other user it never affect. You got it, right? So what's my conclusion? If you go for the unicast, we wasting a lot of bandwidth and we wasting a lot of process, because for each packet we wanted to process for unicast. But if you go for the broadcast, we saving bandwidth but we wasting lot of process. Okay, to go and hit unnecessarily to all the router. And if you go for the multicast, we saving bandwidth as well as we saving the process. That's the best technology to use for video and audio traffic. Cisco recommend to use UDP as the transport protocol for multicast traffic. Okay, so you know that we have UDP and TCP. Actually TCP we cannot use for the multicast traffic. That means we cannot use for the audio or video traffic, we cannot use it. The reason was it's a video and audio traffic was a delay sensitive. You got it, right? If you go for the TCP, okay, so it has acknowledgement. If any packet loss, it will be retransmitted. Actually, you know that video and audio traffic, it was a very delay sensitive. You know about the live stream. When you talk, you got it, right? The delay is supposed to be maintained. 150 milliseconds must be maintained. Okay, that retransmission and all, it's not make a normal voice or normal video stream. Okay, so that's the reason we not using the TCP technology. Okay, it's recommended to use for the UDP technology. Okay, and one more thing, by default router never support the multicast traffic. Okay, it only support the unicast traffic, it never support broadcast also. If you wanted to router wanted to forward a multicast traffic, you should enable IP multicast routing command, you should enable globally. Okay, so then it can forward the multicast traffic. And we have two type of communication in the multicast technology. One is the IGMP communication and one more is the PIM communication. So IGMP communication we use it between the PC and routers. PIM communication we use it between the router. Okay, so this communication will help to multicast work properly. You got it? Without the communication it cannot work properly. So we want the PIM communication between the router, and IGMP communication we need between the router and PC. So Cisco recommend to use UDP as a transport protocol for the voice and audio traffic. Okay, you cannot use for the TCP. Okay, TCP has the acknowledgement process. If any packet losses happen, so TCP protocol will be retransmit. Okay, so that takes some delay. Okay, but if you go for UDP, there is no retransmission process and there is no acknowledgement process. Okay, so if you go for the TCP, it takes some delay. Actually, you know that audio and video traffic, it's a delay sensitive traffic. You cannot go for the TCP. If you go for the TCP, it affects the audio and video delay effect. You got it? Huh? You better go for the UDP, so that is Cisco recommended that. Okay, you got it right. So and router by default never support the multicast traffic and broadcast traffic also. It only by default support the unicast traffic. If you want, when you give the show IP route, it show the routing table. So IP routing is by default enabled on the router. Okay, if you wanted to forward the multicast traffic through the router, if you want router want to process the multicast traffic, okay, you should enable IP multicast routing command. You should enable on globally. Okay, then it can forward the multicast traffic. It can send and receive. It can process the traffic. Okay, and we have two type of communication we using in the multicast technology. One communication called IGMP and one more communication called PIM. IGMP communication we use it between the PC and routers. Okay, PIM communication we will use between the routers. You got it, right? So this technology will be help so multicast work properly. Without the technology, multicast cannot work properly. In IGMP communication we have three version 1, version 2, version 3. Okay, so in PIM communication we have three modes. One is the dense mode, one more mode is the sparse mode, and one more mode is the sparse dense mode. So in IGMP communication we have three version 1, version 2, version 3. You know that IGMP communication we use it between the PC and router. Okay, so in version 1 we don't have any other option. There is nothing feature, just straightforward the communication between the PC and router. That's it. In version 2 we have an option, that is the leave message. Okay, that leave message will be used to help, or you can stop the multicast traffic at any time. You can stop. So, okay, in the version 1 that feature was not available. It's take long delay to stop the multicast traffic, but in version 2 we have leave message feature. That message will be help to immediately stop the multicast traffic. If you go for version 3, there we have leave message option also is there, and one more option also we have. So that second option called as the source specific multicast. Okay, so that only support in the version 3. Okay, so in version 3 we have the source specific multicast feature we have. So that feature you can choose, just assume for example we have 3 multicast server we have. I am talking about source. We have 3 multicast server, so all 3 multicast server generating the same source, same stream it generating. Okay, so I wanted to choose some specific source I wanted to choose. So that option available in the version 3. You got it right? So that option available in the version 3. So next we will going to talk about the PIM communication. In PIM communication also we have 3 modes: PIM dense mode, PIM sparse mode, and PIM sparse dense mode we have. PIM dense mode it doesn't have the scalability. Okay, and one more thing I can say, it's a flood and pruning behavior. Okay, so dense mode will it only suitable for the small environment. It is only suitable for the small and medium size company. When you go for the large company, it's not suitable. So for that you should go for the sparse mode, or you should go for the sparse dense mode. You got it right? So today introduction class is over. Okay, so next session we're going to talk about sparse mode, sparse dense mode, and PIM dense mode. We're going to talk, as well as we're going to talk about the practical. Okay, today this session is over.